We got a short little lesson here on perimeters and areas of similar figures. So here we go. We'll start right out with a theorem, and this is the big thing that you got to remember for the day. If the scale factor of two similar figures is A over B, the ratio of their perimeters is A over B, the ratio of their areas is A squared over B squared. So the rest of the lesson, we're just going to spend trying that out, putting that into play. So here we go. We got trapezoids here that are similar. What is the scale factor? How do I find the scale factor of similar figures? I just take the ratio of any two corresponding sides. So the scale factor, which I'll abbreviate as SF oftentimes, is 6 over 9. And if we simplify that, we got 2/3. There's my scale factor, 2/3 or 2 to 3. Right? Remember, sometimes we write it like that also. We want to keep these as fractions though. All right, and so what we know here is that this 2 to 3 is A over B. That's the scale factor. That's also the ratio of the perimeters. So that's also P1 to P2, A over B. All right, so that answers the first part. What is the ratio of the areas? Well, I know the ratio of the areas is A squared over B squared, because that's what I just learned in the theorem above. So I'm going to use my simplified scale factor, my simplified A over B. So that's going to be 2 squared over 3 squared, which is 4/9. So there's the ratio of my areas. So if I told you that, let's just say, for example, if I told you the area of this, well, actually there's one just below, so I don't want to make up numbers because they might not come out nice. So let's just do this example right here. I think it's making the point I was going to try to make. The scale factor of two similar parallelograms is 3 to 4. So scale factor is 3 to 4. I'm going to write it as a fraction. So I know that's A over B. Scale factors, A over B, 3 to 4. The area of the larger parallelogram is 96 square inches. What's the area of the smaller parallelogram? So I know that the area of the first one to the second one is A squared over B squared, which is 3 squared over 4 squared, which is 9/16. So that's A1 over A2. Remember that from I'll just put it right here, A1 over A2. So there's the ratio of our areas. Okay, we know the area of the larger one, which we're going to call A2, it's 96. What we don't know is A1. And we also know that that's 9/16, A squared to B squared. All right, so there's our proportion we got to solve to find the area of that smaller trapezoid. What are we going to do here, guys? We're going to use one of our properties of proportions. Couldn't think of my word. And what I'm going to do is I'm going to switch these two things, my two extremes, right? So what I'm going to have is 16 over 96, come up here a little bit, equals 9 over A1. Why do I want to do that? Oh, because 16 over 96 is 1/6. So now I don't have to multiply 9 by 96 and try to figure out what that is. I got it right here. The area of the smaller trapezoid is 54 square inches. Okay, so that's how we're going to use this little theorem we just learned today. Here's another one. In the problem above, the perimeter of the larger parallelogram, so I'm going to call that P2, is 32 inches. What's the perimeter of the smaller one? Well, we got to remember the ratio of the perimeters is the same as the scale factor, which was, what was it? 3 to 4. 3 to 4. So P1 is what I don't know. I do know the perimeter of the second. It's 32. That's 3 to 4. So again, I'm going to switch my means, I think I might have called them the extremes a minute ago. It doesn't matter. You could switch any of the two, the means or extremes. And when I do that, I get 4 over 32 equals 3 over the perimeter. That's 1/8 equals 3 over P1. So I get a nice simple multiplication problem that gives me P1 is 24 inches. Okay, that's how we use this. Okay, you got 2 problems here. This is all that's left. 2 practice problems. Do pause here and do these, and I'll put the solutions up for you. Okay, the triangles below are similar. What is the scale factor? Well, I don't know a ratio between any set of corresponding sides. So what I got to do is I got to start with the areas. They give me the areas. I know that the ratio of the areas is a squared over b squared, so I have to use that to find a over b. And that's what I did right here in this step. I put the ratio of the areas down, simplified it, got 25 over 49. This is a squared to b squared, right? But what I'm looking for is a over b. So what do I do? To get a over b, I got to take the square root of a squared over b squared. And luckily, these are both perfect squares. And when I take the square root of those, I get 5/7. That's the scale factor. It's also the ratio of their perimeters. All right, a similar thing, no pun intended, down here. I've got similar rectangles. Their areas are given. 27 inches squared, 48 inches squared. They tell me the length of one side of the larger one is 16. So right away, I know this other length is 3 because I know the area is base times height. So that's got to be 3 inches right there. But what I want to do is find the lengths of the sides of the smaller rectangle. So just like I did above, I got to start with the areas. A1 over A2 is 27 over 48. I simplify that, I get 9/16. And I know the ratio of the areas is a squared over b squared, so I take the square root of that, get my scale factor. My a over b is 3/4. All right, then I use that right here to set up this proportion, right? I know that x over 16, that's this side, x over 16 is this side over this side, and I know that's the scale factor because those are corresponding sides. So the scale factor is 3/4, because remember that's my a over b. And then I just solve that proportion. I get that this side length right here is 12 inches. And then to get the side length, the other side length of this rectangle, which I called y, I said the area is 27. And that's the base times the height. I got the 12 now, so I just divide the 12 into the 27 to get the height, and I get 9/4 inches, and that's how you use theorem 10-7 to find missing parts of similar figures.